All right, let's dive in. Today, we're not just going to memorize some math rules. Nope, we are building a toolkit, a powerful one. It's going to let us manipulate graphs. Think of it like learning Photoshop, but for functions. It's pretty cool. Let's get into it.
So what if you could just reach into a graph, grab a line, and just move it around? Slide it up, slide it down, left, right, maybe even stretch it out or squish it together, just like a picture in an app. Well, it turns out you totally can. That's exactly what function transformations are all about. And by the time we're done here, you'll be doing it like a pro.
Okay, so our first tool in this new kit, let's call it the shifter. Super simple idea here. This tool is all about changing a line's position, where it is on the graph, without messing with its steepness or direction. We're literally just sliding it around.
Now, the fancy math term for this is a translation, and it's actually a really elegant idea. Imagine every single point on that line, every one of them, moves the exact same distance in the exact same direction. So the line itself doesn't bend or twist or anything, it stays perfectly rigid. It just ends up in a new location.
Okay, so here's where it gets interesting. We can break these shifts or translations into two types. Vertical, that's up and down, and horizontal, left and right. And this is the crucial part. The vertical ones, they're super intuitive. They work exactly how you think they would. But the horizontal ones? They've got a little twist, a little surprise waiting for you.
So let's start with the easy one, right? Vertical shifts. If we want to move a line up or down, all we have to do is add or subtract a number from the whole function. That's it. It's so straightforward, and we've got a really simple trick to remember it.
Here it is. Just think same. That's the mantra. You want to move the graph up by 5? You add 5 to the function. You want to move it down by 2? You subtract 2. The sign does exactly what your gut tells you it should. See? Simple.
Okay, you ready? Now for the fun part. We're talking horizontal shifts now, left and right. And this is where our intuition just totally gets thrown for a loop. Seriously, this is the one spot where almost everyone gets tripped up when they're first learning.
Just look at this. If you want to move a line to the left, towards the negative side of the graph, you actually add. And to move it to the right, towards the positive side, you subtract. I know, it feels completely backward. But trust me, there's a good reason for it, and more importantly, a foolproof way to remember it.
And here it is, the golden rule you need to burn into your brain for horizontal shifts. Think opposite. That's it. Whatever the sign is doing inside the parentheses with the x, the graph does the exact opposite. You see a plus sign, the graph moves left. You see a minus sign, the graph moves right. Once you get that, I promise you'll never get this wrong again.
Okay, let's put this into practice. Let's say we want to shift the function f of x equals 2x plus 3, 3 units to the left. All right, what's the rule? Think opposite. So a left shift means we're going to add 3. But, and this is key, we add it only to the x. We replace the x with a whole x plus 3. See that in step 2? So now we have 2 times x plus 3 plus that original 3. We just simplify that out, and boom, our new function is 2x plus 9. That's the rule in action, right there.
All right, so we've got the whole sliding thing down. We're masters of the shifter. Time to grab the next tool from our kit. I'm calling this one the resizer. And like the name says, this isn't about moving the line anymore. This is about changing its actual shape, or more specifically, its slope.
Yeah, so translations just moved the graph, right? Stretches and compressions, they fundamentally alter it. We're either going to stretch it out, making it steeper, or we're going to squash it down, making it flatter. So we're not just changing its address on the graph anymore, we're changing a core part of its identity, its slope.
This table lays it all out perfectly. Check this out. See how a vertical stretch, that's pulling it taller, and a horizontal compression, squeezing it in from the sides, actually do the same thing? They both make the line steeper. And look at the flip side. Squashing it vertically or stretching it wide horizontally both make it flatter. Kind of cool, right? It means there's often more than one way to get the same look.
And hey, guess what? That think opposite idea we just mastered for horizontal shifts, it's about to make a comeback. Because just like before, the vertical stuff is totally intuitive. You just multiply the whole function. But the horizontal stretches and compressions, yeah, they've got their own special trick up their sleeve.
And here's the trick. For anything horizontal that involves resizing, you don't just multiply by the number they give you. No, you have to multiply the x by its reciprocal. You flip the fraction.
This is basically the think opposite rule, just for multiplication.
Okay, let's walk through this one. We need to compress the line horizontally by a factor of 1/3. So what's the rule? Reciprocal. The reciprocal of 1/3 is 3. Easy enough. So we go back to our function and we replace every single x with 3x. That gives us 2 times 3x minus 1. Simple math, and we get 6x minus 1. But hang on a second. Notice what happened. We compressed it, but the slope got bigger. The line got steeper. It's that opposite logic hitting us again. It works every time.
Okay, now for what I think is the coolest part. All these tools we've been talking about, the shifter, the resizer, they're great on their own. But their real power, their true potential, is unlocked when you start using them together. You start combining them, stacking them one after another to sculpt a line into exactly what you need.
Think about it. In the real world, you're not just going to do one thing. You might need to make a line flatter and then shift it up. To do that, you just apply your tools one at a time in order. Let's see how this plays out with the simplest line in existence, our good old parent function, f of x equals x.
All right, here's the recipe. We're starting with f of x equals x. Step 1, we're going to vertically compress it by a factor of 1/2. That'll make it flatter. Step 2, once we've done that, we're going to take that new, flatter line and just shift the whole thing down by 6 units. 2 steps.
And here's what we get. The vertical compression, that's tool number 1, we multiply the whole function by 1/2. So x becomes 1/2 x. Then tool number 2, the vertical shift down. We subtract 6 from that result. And there's our final answer. G of x equals 1/2 x minus 6. See? We just built a totally new function, one piece at a time.
Woo! Okay, we've gone through a lot. So let's bring it all home. Think of this last slide as your master toolkit, your ultimate cheat sheet. Everything we've talked about all in one handy spot.
And there you have it, the whole shebang. 4 fundamental rules. And now you can really see the pattern, right? The vertical stuff happens outside the function. It affects the whole f of x. But the horizontal stuff, that happens inside the parentheses, messing directly with the x. And those horizontal ones always have that weird counterintuitive twist. Opposite for sliding, reciprocal for resizing. That's the entire system right there. So, I'll leave you with this final thought. We've spent this whole time mastering this toolkit for straight lines. But here's the really powerful secret. These rules, they work for any function, for anything you can graph. So my question to you is, what do you think would happen if you took these exact same tools, think opposite, think reciprocal, and you applied them not to a simple line, but to something with curves, like a parabola? Now that's where this stuff starts to get really, really cool.